Alright guys, checking out this problem, given the two vectors v and w, graph each and then show the resultant vector. Well, for part A, what we're looking at is the combination of these two vectors. And so what we want to do is this vector tells us that it goes 2 in the x direction. This vector tells us that it goes 3 in the x direction. And so what happens is when we combine these two and we get v plus w, the combined vector is actually going to go 2 plus 3 in the x direction. So there are a couple different ways that we can look at this. First, we can look at this just using the components that we talked about the other day. So v plus w is actually going to go 2 plus 3 in the x direction, or 5 in the x direction. The other part is in the y direction, or using the y components. V plus w is going to go 4 plus 1 in the y direction. And obviously we want to simplify this, so adding these two vectors together we would get a resultant vector of 5, 5. The other way that we can look at this is the graphical method, and we'll talk a little bit more about this in a second, but the graphical method essentially is just going to look at this vector and then tacking this vector on to the tail of that vector. So our first vector goes 2 in the x and 4 in the y. So 2 in the x, 4 in the y is going to take us up to here. And we're going to get a vector that looks like this. That is vector v. And then vector w is going to go an additional 3 units in the x and an additional 1 in the y. So we're going to get something that looks like this. Additional 3 in the x, 1 in the y is going to take us to here. That's vector w. And so what we're left with is what we call the resultant vector, as we talked about the other day. And the resultant vector is going to take both of these into consideration and give us something that looks like this. So we can look back up here and kind of algebraically, or just taking each component into consideration and adding those together, we end up with a vector that looks like 5, 5. 5 in the x, 1, 2, 3, 4, 5 in the x, and 1, 2, 3, 4, 5 in the y. So that's this blue vector. So we would label this blue vector v plus w. So it's a combination of those two vectors, and this would be our resultant vector. Alright, coming over here, we're going to take the same approach over here. This time we want v minus w. So again, v is going to take us 2 in the x direction. And then the opposite of where w is going, w is going 3, 1. So we want to go in the opposite direction of that. Well, 3, 1 looks like this. So the opposite would just be the flip. We're going to go negative 3 and then down 1. So the opposite direction is going to take us negative 3, negative 1. When we take the x components of v and then subtract w, we end up with a negative 1. The y components, 4, and then the opposite of 1 is going to be 4 minus 1, or 3. So our resultant vector should look like this. Here again, we want to graph these two vectors kind of in concert with one another. The first one takes us 2, 4. So again, the first one's going to look the same. The second vector is going to take us 3, 1. So w would actually look like this. But what we want to do is we want to take that vector and just flip it on its head so that it's actually going in the opposite direction. So it looks something like that. And it should take us to negative 1, 3. So let's just plot it and make sure that it does. Negative 1 in the x direction, 3 in the y direction gives us a resultant vector of this. So just to label what's going on up here, again we've got v and then negative w, and v minus w is going to be our resultant vector. and that's what it looks like. So just to kind of summarize this rule, anytime we combine or add vectors, or subtract for that matter, obviously addition and subtraction are going to be opposite operations, but we use what we call the head to tail method. All right, so we're going to start with whatever vector that's listed first, and in this case we're going to combine 6, 5 and negative 2, 1. So I'm going to take 6, 5, which looks like this. I'm going to plot it from the origin, and negative 2, 1 looks like this. And what I'm going to do is tack the head, or the initial point of negative 2, 1 onto the tail of 6, 5. We're going to get something that looks like this. Our resultant vector, again, obviously would be the starting point, and that's a little curve, but you guys get the idea. There's my resultant vector. Last thing I want to note is that it doesn't matter the order in which you operate these. So v plus w is actually going to be the same as w plus v. So it doesn't matter if I plot this one first. Here is the second vector in our example, and we're going to plot that vector, and we're going to use that head to tail method and plot that second vector head to tail with the first, and you can see that it's going to land us in that same general, or in that same point right here, and give us the same resultant vector. So it doesn't matter the order in which you apply these. If we use this head to tail method, it should give you the same result.